Good evening, everyone. I am Paulo Goes. I'm the Dean of the Freeman School of Business here at Tulane. We are so excited to be hosting this event tonight, so welcome to the future. And here at the Freeman School, we are shaping the future of business education. So it's very aligned with the theme of this event. We are going to embark on a journey to infinity and beyond with our own Captain Picard, aka Cliff Farrah. In a moment, he also wrote a very popular book about that. You can see Growing the Topline. Very interesting insights. But when you work on growth, that's what you do. You look into the future. In a few minutes, we will all do the same through this guided tour. Cliff is currently the Chief Strategy Officer for Global Corporate Strategy and Growth at Accenture. And more important, Center, Carmen Weigelt, of our speaker series, and particularly for extending the support to our Futurist series. Thank you. Now let's bring Captain Cliff Farrah to take us into the future. All on board on the Enterprise, energize.
Thank you, Paulo. Well, I can just throw away 2, 3, 4 of these here. Look, Tulane's super special to our family, and my wife and kids couldn't be here tonight, but they're watching at home, so wherever the camera is, guys, good to see you. But I met my wife in New Orleans and fell in love with her 30 years ago, and she was a student at Tulane at the time. Whirlwind romance. We convinced our kids to go to school here, and they're both very happy and successful grads from the school. So it was inevitable that one day I would somehow be involved in the school, since you wouldn't admit me when I wanted to come here. And I started talking with Dean Goes a bit about what I was seeing in the market, right? That there's this gap between what you can learn in school, arguably in a quality education with a curriculum that exists today that's market leading, world leading, and just the realities of the changing work environment. And so, you know, I've been very impressed as I've watched the school over time, you know, sort of push that forward thinking onto its student base. I had a chance to come in and work with Carmen in her class, and tomorrow, I'm going to steal Rob, who I'll introduce in a minute, and we're going to help in one of the capstone consulting classes. So that should be really fun as well. But I was really impressed by the interest in arming students to be better prepared, better competitors in the marketplace. And so that's the intent of this series. The intent of this series, the hope is that if you're a student or a grad or an alum of the school, whether you're an employer or an employee, that we get to apply 5 degrees of rudder to your journey, right? That we make you lift your head and think about how things are changing and how you can take advantage of that in your own career. We should all be futurists. So what is a futurist? That always comes up. That's pretty bold to call yourself a futurist in this community. And by the way, Freeman family, my Lord, what a facility you've got here for the school. It's just inspirational, and inspirational environments inspire great thought. So kudos to you. I hope nobody in this room takes it for granted. But when you think about in particular what a futurist does is they absorb information, they analyze the information, and they think about potential outcomes. So there's a lot of game theory, and you start to think 2 and 3 and 4 chess moves out. What could be? What might be? What would it mean? Why would it be that way? What should I do about it? And historically, futurists have been kind of frowned upon in our industry because it's almost impossible to predict the future, right? But now we have more information than ever. And in fact, anyone who uses ChatGPT is using a futurist, because the entirety of the architecture of any large language model is, in fact, prediction of the future, right? So we all need to take a moment and pay attention to how the markets are changing. And I've reached out to some amazing not just thought leaders, but market creators to help me talk to y'all a little bit. And I hope that's what this is. I hope it's a discussion. We have a Q&A session at the end. We're going to talk first for about an hour. And in the Q&A session, if you're bold enough to ask a question, I will give you a signed copy inscribed to you of this book after the event, free, no charge, right? Anyway, I do want to first demonstrate a use case for AI because I didn't have time really to prepare to introduce my speakers. So I did what every speaker does. I went to my large language model. So I'm going to start with Ben Carey. Everything that I say at this point, I did not write, okay? All right. Ben is Senior Managing Director at Accenture and America's Growth and Strategy Lead. For a sense of scale, the Americas organization represented $30 billion in sales last year, or nearly half of Accenture's revenue and employee base, which worldwide, Accenture is now over 800,000 employees. Okay? Ben built his career helping companies turn AI from hype into real results, and I'm excited to hear him talk about it later. Remember, AI wrote that. But here's the part that makes tonight extra special. Ben is one of our own. He's a proud alumnus of the Freeman School, both undergraduate and MBA. He sat in the same classrooms, drank the same PJ's coffee, and let's be honest, probably pulled some of the same all-nighters at Snake and Jake's that our current students do today. And for our students, he's living proof that you can start in New Orleans and go on to drive the future of technology on a global stage. So Ben, welcome home.
Thank you. I'm excited to be back here, and I just want to say, one of my friends was on campus last week, and he took a picture of the lawn sign that was promoting this event. And I was very excited because I've always wanted to be a face on a lawn sign. I thought I'd have to become a realtor to do that, and now I realize I don't, so thank you for that.
Love it. Now let's talk about Dr. GB Raphael. GB, raise your hand. Okay. GB is the founder and CEO of Robotics, and he's going to talk about that today. GB, can you show the logo? There it is, right there. And when it comes to education, let's just say that GB makes the rest of us feel like underachievers. From USC, he holds not one, not two, but 3 Master of Science degrees in computer science, biomedical engineering, and electrical engineering. Not content with that, he went on to earn a PhD in robotics and machine learning, and because that clearly wasn't enough, he decided to top it off with an MBA in finance from Cornell. At that point, most people would take a nap. GB went to DARPA, where he wrote the AI interface to connect brain signals to robotic prosthetics for wounded veterans, and then Intel, where he served as general manager of their intelligent immersive augmentation team, and that's where he and I first worked together. His career spans engineering, leadership, and entrepreneurship, and at Robotics, he's now building AI training systems focused on physical AI, which if you haven't heard of, we'll talk about today, where humans and machines collaborate in ways that were once science fiction. Jean-Luc would be happy. Didn't say that. Okay, and last but not least, Rob Hayes. Yes. Rob is the former CEO of Atom Computing, one of the true pioneers in scalable quantum computing, working with neutral atom systems. We'll dig into it, but think about making the world's most powerful computers from $200 tanks of inert gas you can buy at your local welding supply store, controlled at the atomic level with laser forceps, and run at room temperature with the energy consumption of your 4-bedroom off-campus apartment on Willow. Pure disruption. AI wrote that again. Rob spent 21 years at Intel serving as Vice President and Chief Strategy Officer of Intel's data center group, which when he left in 2019 sold over $30 billion. Rob later served as Vice President and Chief Strategy Officer for Lenovo's Infrastructure Solutions Group, the $8 billion data center arm of the company. Rob has literally architected the infrastructure that powers the internet today, and now he's turning his expertise to building the quantum future. He brings a rare perspective on how computing power from classical to quantum will transform the world. So that's our roundtable, a Freeman alum shaping AI adoption for global enterprise, a robotics visionary building machines of the future, and a quantum pioneer who has helped turn theory into practice. Together, they're going to help us explore what disruption means, where it's taking us, and what role all of us, students, alumni, professionals, will play in shaping the decade ahead. So please join me in welcoming our first Freeman Futurist panel, Ben, Rob, and GB. All AI written over a bowl of oatmeal in the morning, okay? And I'm joking, but at the end of the day, efficiency through the use of AI is one of the primary value drivers that we're seeing in the marketplace. What I'm going to do right now is sort of, I'm going to make a disclaimer, okay? We are up here as individuals. We do not represent the companies that we work for today. These are our own opinions, our own thought, based on our own experience and knowledge. We cannot violate any IP agreements, NDAs, things we should not share, we will not share. But we're incredibly informed on these topics, and we're happy to answer questions you might have and invite you to a dialogue like we had last night at GoTros. Yes? Okay. So we're going to structure this into basically 3 kinds of conversation, okay? One is just level set for y'all where we are today. Like what's actually happening, not locker room talk, not generality that you might pick up, but actually what is deploying today in each of these domains? How far along is it? What's the timing look like? What's the potential impact look like, okay? Then we're going to talk about the future state. So this is where the market is going. And as futurists, we should paint alternate endpoints on this, right? We should talk about how they might go and how we think they will go, and we will do that. And then ultimately, what should we do about it? Like, what is the practical, useful motion you can take away from this session today to be more informed, better armed, more successful as you go forward in this future state world? Okay? Good. Hey, Ben, I'm going to start with you. Can you tell the audience your take on AI deployment today in enterprise?
Yeah. So maybe just to ground a little bit on it, AI is not new. And I think that's one of the most important things to keep in mind as we think about, where are we today? We're on a journey that's, at a certain point is continue on. We've had task-specific AI for many, many years. We've called many things AI for many years. We have machine learning. We've used machine learning for many years. Most recently, everyone has been talking about generative AI and then agentic AI. So, AI that actually creates material, and then AI that replaces a role and actually serves as an agent or serves a role like a person would. And what's coming next is, more orchestrated AI. So think of multiple agents working together to solve problems, or maybe hybrid AI, so humans and agents working in seamlessly. And then, of course, when you get to artificial general intelligence, then the possibilities are truly endless. So we're on this journey, and it's not new. The second point I would make about it is it's combinatorial. AI is built on a foundation of a lot of other technologies that have become accepted and used everywhere, and that we are as common as email today. But it's dependent on cloud. It uses a digital interface. Of course, it's built on a foundation that includes the internet, and of course, it has a data foundation. So it's not new. It's combinatorial, and the fact that it's on this journey and that it will continue to advance, and that the other technologies around it will continue to advance, means that it will rapidly change in terms of what the capability has and how it will be used. And I think that's one of the interesting things we'll explore today together is that when you think about AI in combination with robotics or quantum computing, it's tremendously different in terms of what could be in the future.
Can I interrupt for 1 second?
Yeah.
Because that was a high caloric meal. If you're not familiar with AI fluently, let's just take it back one step.
Yeah.
So, November 2022, OpenAI launches ChatGPT, and the world changed, right? Because we'd had AI, but the world changed on that date. Why did the world change? Like, what was it about ChatGPT that made Google look flawed?
Well, the main thing about ChatGPT is it exposed to the public a use case that was interesting and captivating. And so it really allowed everybody to see, oh, there's something I can do with this, and it's interesting. I mean, I kind of was reflecting earlier in a conversation that, I knew things were a little bit weird with AI when my 90-year-old uncle started using it, and I was like, well, that's pretty amazing. And so virtually, probably everyone in this room has used, ChatGPT or some derivative thereof. And that's pretty remarkable because when you think about technology adoption, it probably took a lot longer for everybody in the room to get a BlackBerry and maybe even migrate to an iPhone. So it's a technology that has captivated people, and it's clear that it can do something that's interesting and useful, and we've all found a way to use it.
And I believe, and guys chime in on this too. I believe it's because it's so familiar, right? That you write it a sentence, it talks to you, in our case, in English. It's logical. It actually has better grammar than any of us, and it's an easy to use, powerful tool that we can use for just about anything, right?
Yeah.
Okay.
It can. Well, I mean, yes, but the question is it creating value? And I think that's where we really get to the rub. And there was a recent study that was done by MIT that showed that 95% of investments that have been made in AI have returned close to nothing, really almost no return. And so companies are running headlong into this new technology because it is important and it is something they know can change their business, but too few of them are actually extracting value from it. So yes, you can play around with it and do some cool stuff, and you can have a bunch of use cases that captivate people and maybe increase your productivity around the margins. But unless you're actually changing the work, you're not creating value. And I think that's where we see a lot of people struggling is this paradox of it's an incredibly powerful technology, it's pervasive, it's something everyone is investing in and knows they need to continue to invest in, but they haven't really found a way to extract the value out of it yet.
So Ben, can I add
please.
a quick one? So I think that one of the disruptions that ChatGPT brought AI to words. Okay, so 2007, there's a professor called Fifi Lee in Stanford. She was at Princeton at that time. She had this idea of ImageNet. Can you classify cats and dogs? But that was an image.
Right.
And it was helpful, but a pixel doesn't connect with another pixel. So when it gets to words, context is important. So finally, it brought it down to something you can talk to, converse, and understand the context.
Relatable.
That was a huge disruption to your point.
Yeah.
Right? So that your 90-year-old grandfather could use it finally.
Yeah, exactly. I think that's true. And so there's a tremendous promise, but actually harnessing that promise and
Totally true.
is really the challenge.
So I'm going to dig in this just one more turn of the crank, and then I'm going to go to you, GB, to help set the stage, and then we'll get to Rob, and then we'll bring it back and we'll play jazz, right? We'll have the keynotes we have to hit, and then we're just going to how we get there. We're going to see. So we're talking about, when you say they're not extracting value, you're talking largely about companies, enterprise.
Enterprises are struggling to really get the value out of it, and I think that's part of the role that each of us has to play in terms of how we use AI out in the world. I mean, it's great that we can, edit a video and add a cat to a picture, but what really matters for each of us as we go into a professional world is how we actually create value with it, how we turn it into something that's useful for our company and for society.
Okay, so dig for 1 second on the functional areas that you think inside an enterprise are actually creating value today through the use of AI.
Well, I'll give a functional example, and I think there are places where it is creating value. I think, while many are underwhelmed by the value that it's created, there's no doubt that it will create value over time. But legal is a great example. I mean, legal reviews are happening a lot faster, and many people in the legal profession are using AI fairly effectively. Sure, there's some headline examples of court cases where you see people have used hallucination references, et cetera. But the vast majority of simple contract review is dramatically accelerated today. So that's a good use case, very simple, very easy to grasp. Everyone is. It is something that there's a lot of routine legal work that can be done much more efficiently analyzing contracts and spend for procurement organizations. That's another one that's very easy to use and can create some value. But the majority of companies are using, have use case examples. They're launching pilots. They're experimenting. They're teaching their teams, making people sort of familiar with the technology, which is all good foundational stuff.
Yeah.
But they haven't re-engineered the actual work. They haven't changed their business processes. They haven't rethought how what sort of data foundation is required to be more effective in the future. They haven't, thought about what work is being done where and what's going to be replaced and how it will be replaced. So that holistic, look at the work is really what's missing from most AI initiatives today.
So pragmatically then, for the folks in the audience, if I were to translate that a little bit, it would be the challenge at this point is that the management systems of companies have not yet adjusted to and migrated to the capabilities of an AI-driven future, which is for pending graduates, like the students who are in school right now. I use this one-liner all the time, but you are the first cohort that is going to graduate and be expected to be fluent in the toolkit that AI provides, right? And you all use Boodlebox, which I'm in love with. I've had a chance to work with it. I think it's a phenomenal product. But if the organizations haven't yet caught up, if the management systems haven't caught up, if the training hasn't caught up, then the reality is the job you're hired into initially is going to be vastly different in 4 or 5 years than the job you're doing today. And I think that is a truth, yes, that we can arguably say that due to AI, there will be wholesale transformation in how we do work in the enterprise.
Yeah, the CEO of Walmart says 100% of Walmart employees' jobs will be impacted by AI. That's a pretty amazing statement for a business that has a large majority of hourly employees. So yes, it will change work.
So Cliff, I have a very personal example, if I may.
Please.
Talk about how AI has literally changed my household. So my wife is a internal medicine physician. She sees about 20 patients a day. And this was our household prior to AI. She comes home, she has to write notes for all those 20 patients she saw. And she doesn't get time in the office to do that. She comes home, waits, takes 3-4 hours at night, the time she should be spending with me, our kids, and all that. Sleeps at 1 o'clock at night, writing up the notes. But literally how it happens today is, when she talks to the patient, with their approval, she puts a smartphone next to the patient. The hospital has an app that hospital has given her. And by the time she's finished talking to that one patient, by the time she gets back to her office, the whole notes is written, and including the diagnosis and prognosis. And she takes like literally 5 minutes to make sure everything is written correctly and submits the note. There's literally, taken 3-4 hours a day is given back to her family every day. So that, I can't deny the power of AI in my family.
Time is our most precious asset.
That's right.
Yeah.
Right? Okay. We're in the table setting mode now, right? So we just talked about AI. It's finding its way into enterprise. Enterprise is learning how to best deploy it. They're working through proof of concepts, pilots, and actual deployments. There's, as humans, I think, pretty good penetration for all of us that we're using AI. I think, what was the stat recently published here at Tulane that 87% of the students said they're using AI in their coursework in some fashion. And my opinion is, the remaining 13% just don't realize that they're using it somehow in their coursework. One of the things about, so we're talking about AI, robotics, and quantum. So why robotics? Like, why would we talk about robotics? Well, AI is largely a digital environment, right? So we get influenced by it. It gives us advice. It gives us an answer, and we change our behavior. We do something in the physical world based on the influence of AI, yes? So the human is the interface between digital and physical. Well, that's kind of a a flawed model for large-scale enterprise because we have a shortage right now of humans in the world, especially in America. And we have an aging population in America, and they're taking a lot of knowledge out of the workforce. We had the pandemic. We had 1 million incremental deaths that we didn't plan for. And then for folks my age, we were all like, holy crap, we could have died. Let's retire early. We have enough. And so there was a secondary ring of retirement that occurred, straining the labor force. Final piece of the trifecta is that the current administration has put in place policies that make labor and skilled labor more friction-filled to get into the country. It's getting scarcer. So we need an alternate. We need a way to solve for this. And I don't think that it's a surprise to anyone that robotics is one of the keys to answering that as we move forward, especially in the United States, right now. So, Dr. Raphael, GB, my friend, can you paint a bit of a picture about the state of affairs in robots today, and maybe a little bit about Revobots and its particular philosophy?
Absolutely. Thank you, Cliff. Happy to be here. The fundamental assumption is that the same day world changed with ChatGPT, it also changed for robotics. So the fundamental assumption is that just like how you can predict each word and put together a sentence, you can actually predict actions and learn actions. So how robotics used to work before all those technology AI came was, if you want to deploy a robot, you spend a couple of $1 million, and you send a robotics engineer who would come in, look at the situation, and start programming. The problem is you can't program more than 50 steps. I mean, an average task has hundreds of steps. You cannot program all that. Even if you program one variation of it, there are hundreds of variations you have to program. But what ChatGPT or generative AI has shown us is, just like how you learn words and predict words, you can take it to what they call physical AI. With some tweaks, you can learn actions. So in robotic terminology, they call it imitation learning. You can show the robot how it is done, and the robot can look at you, how you're doing it, and learn how to repeat it. So there is a fundamental disruption going on, and it's an inflection point for robotics for two reasons. One is AI, and the other one is, if you can really replicate a human task, what better embodiment than a robot that looks like a human? So hence the rise of humanoids. Robots with two arms, and you can walk around, same height, 5'9", and can do all the things a human does. So the combination of these two, it's going to be revolutionary. The state of affairs today is, I think it was Farrah who predicted by the end of this decade, there will be 85 million blue-collar jobs unfilled. We often think robots are coming for your jobs, but it's almost the opposite. There are jobs that we call the 4D tasks, right? Dirty, dexterous, dangerous, and dull. Right? You don't want humans to do these tasks. And the other thing that's happening is almost 1 million baby boomers are retiring every month. That's about 100 million baby boomers retiring this decade. So all those spots need to be filled, and we think at Riverbots, what we do is we make robots autonomous. So we bring AI to make robots autonomous, and how we do that is by showing the robot what is to be done and use AI to imitate humans. So that's essentially what we do in Robobots. And in order to get there, let me just finish that also, Cliff.
Please.
In order to get to that world of autonomy, where robots can do, somebody was asking me at the lobby, can the robots sweep the floor? That's not hard. You can do that today. I have robots, customers who want to use these robots to stock shelves, right? These are done at graveyard shifts, and there is a direct correlation to depression and divorce rates due to graveyard shift. Who knew, right? 30% more likely. So you don't need humans to do those jobs. You can have robots do those jobs. Or hotel rooms. There are 5 million hotel rooms in the US. Las Vegas alone has 150,000 hotel rooms. Who's going to clean them? They have to be turned every day or every other day. There are robots that can do that. They can go in and clean the toilet and fluff the bed and fluff the pillows and keep the bed and fix the bed and all those things. So it's coming, and it's only to help, and it's to fill that void of things that humans don't want to do. And the two challenges we see which Robobots is solving today is one is lack of data. You need, generative AI used the internet to train their models, 3 decades of data in the internet. But for robotics, physical AI, you don't have that data. So we are trying to solve that problem.
Wait.
Yeah.
My house is being vacuumed right now by Roomba. What do you mean I don't have that? It is, by the way. What do you mean I don't have the data?
I'll take it to another level, right? People say autonomous cars, how amazing that is. But in the larger scope of things, autonomous cars are not a big deal. I'll just tell you why. The rule book is only 50 pages. That's what you and I learned to get a license. But when you get to unstructured environment, there are a lot of things that you need, variations, and a lot of unpredictable things that the robot has to take care of. And we don't have data for that. You have a lot of data for pick and place, right? That's what robots have been doing for the last 20, 30 years, pick and place. You don't have data to go into a hotel room and clean the hotel room. And by the way, if somebody left their pants there, a robot needs to know what to do with that pants. Or the jacket there, it needs to know what to do with that jacket, right? So it's a very unstructured environment.
We talked earlier about a baby learning.
That's right.
A baby learns.
Yeah.
And one of the things I think is fair in all of this, when we talk about AI and the current generative AI deployments that are happening, they're learning systems, right? Like they get data, they get outcomes, and they form their own neural networks to understand how to behave in order to get those good outcomes.
4 million.
A
baby does 4 million random movements before it can pick up a cup in 1 year or 9 to 10 months. Right?
Think about that. So for a baby, I remember mine. 4 million movements before a cup.
Yeah. Cliff did only 2. He was smart. So.
Oh yeah.
Yeah. So there is no data. So the only way you can get data. So we call our company, deploy and build, right? Not build and deploy. You need to deploy to get data, and you need to bring down the cost of the robot. In my opinion, to democratize robotics, robots did not cost more than a laptop. That's how you get 2 or 3 per household, or many per, a factory. So that's one. Let me just finish one more. The other thing is reliability. We believe that even when you get to L5, which is the highest level of autonomy, you cannot have 100% reliability to deploy these robots. The only way to get to deploy reliability is to put a human brain in the loop with the robot, because you cannot teach common sense to the robot. So how do you put a human brain with the robot? That's a technology we are developing called, we have it, it's called human in the loop system, where the robot may be able to do 90%, 99% autonomous, but you still need 1% human brain in the loop with the robot in order to deploy it reliably. So these are the 2 focuses of our company, and essentially we want to make every robot autonomous. That's the goal.
Whew. Okay, thank you. Rob, I'm going to pivot to you next. Okay, so I'm just going to tie together what we've heard so far. So we have AI deploying at the home, in the workplace. It's mostly a digital interface that is being made physical, potentially in the near term, through the use of low-cost, human-in-the-loop robots. The minute we get into the field of quantum, we are talking Star Trek at that point, right? We are talking step change in almost everything that we've discussed to this point. So, Rob, let's make it a broad quantum, and don't get scared by the word quantum. We're going to break it down, right? But let's do a broad discussion of quantum in its current deployment state, and let's talk about compute, which I think everybody talks about. Let's talk about networking. Let's talk about sensing, and let's talk about quantum clocks.
All right. Well,
In
first
like
of all,
5 minutes or less.
this is a really easy topic.
Yeah, I know.
I just breeze right through
I
it.
know.
So maybe we should just first start with a quick definition. We're talking about quantum. We're talking about the world that's very, very small, seeing interactions of particles at the subatomic level and how things interact with each other. it at that scale is something that is different than the way the world works at a human scale, the things we can observe, with our eyes and our fingers and so forth, and the way we're used to things interacting. So what people are doing with these quantum systems, and I'll say systems in a broad sense, is they're able to harness individual atoms or parts of atoms, electrons, photons, and they're able to very precisely control that behavior and apply that to certain problems that can mimic other quantum systems in the world. So how do molecules interact? How does physics happen at that small scale? And they're applying it to a number of different types of systems, including quantum computers, which we'll talk probably more about. Timing, the most accurate clocks today are atomic clocks. They capture an atom and an optical tweezer, a little stream of photons, and the atom just sort of oscillates at a very high rate, and they can get a very, very precise clock. The most precise clocks on Earth are these. What can you do with a very precise clock? Well, if you couple that with very precise sensing equipment, measuring magnetic fields or motion and things like that, you could actually navigate without the need for GPS or compasses or other things that people use. Government's very interested in that for navigating in a GPS-denied environment like we're seeing, in Ukraine and Israel and places where there's war. One of the things they do is they jam the satellites so that you can't figure out where you are, and that's a real problem if you're a submarine or a ship on the surface or something like that. So they're building these very precise clocks and putting them on ships. They're coupling it with very precise sensors to try to, and motion sensors and things like that to do navigation. MRI machines are quantum machines, right? They're using nuclear magnetic resonance to see through things, through the body. So these systems are already out there. They're using this very peculiar property of quantum systems called entanglement, where you can have two atoms or two particles that can be correlated in a way that they can use something like Bell states, where if one is up and they're entangled, the other one's down, and if you can read one, the state of the other one because of this tight correlation called entanglement, and you can use that for quantum communications. So in theory, this can happen at any distance. So if I have two particles that are entangled and I move them further and further apart, they stay entangled. And you can imagine I can put one on a satellite and one on the surface of the Earth, and I can communicate that way. But if one is ever read, another peculiar state is the communication is stopped and the system resets in a way. So you can use this for secure communication, which is another kind of thing that people are wanting to do with quantum. And then I'll circle back to computing. So people are using these systems that they're building out of trapped ions or neutral atoms and optical tweezers and superconducting circuits and things like that. And they're able to use this other property of quantum systems called superposition, where you can encode not just a 1 or a 0 like in a classical system, where you're either 1 or 0, any bit in a standard computer. In a quantum computer using a quantum bit or a qubit, you can be 1 and 0, you can be multiple positions at the same time, and you can actually encode probabilistic curves like wave functions into each qubit, and you can calculate these massive multivariable problems where every variable is some kind of a wave function or a probability distribution. You can calculate that in a very short order of time to come out with a probable outcome, and you do that enough, you can come out with something you have high confidence that you're getting the right answer, and you can start to model subatomic, molecular, systems that just aren't practical problems on today's quantum computer or today's classical computers. And so now we can start to simulate what very complex molecules and new drugs might look like as they attach to protein receptors and things like that in the body. So we can shrink the amount of time to drug design from what could be years or months to days or hours potentially to find the right candidate molecules much more quickly. And so there's all these different use cases that kind of span a lot of different applications in many different industries. But they're all using quantum mechanics in this sort of field that's been in study for the last 100 years or so, and starting to apply that to some of these, systems that can start to model this stuff.
Who's awake? Anyone awake? All right, good. All right, just checking. Because that was the epitome of a high caloric meal, but I liked it because we are going to Vegas. I heard distribution curves and we can solve for things, and pretty sure we can find some investment
And the
there.
hotel rooms will be clean. So
And the
it's
hotel
good.
rooms will be clean. Rob, I just want to let's make it let's make it more practical in terms of where does this deploy first? And let's just pick. I'm picking on quantum compute because it's the area I know the most about. So I apologize. He could talk about all of this in any way he wanted, but in the compute world, the sense of scale of disruption we're talking about when you think about a quantum computer versus a conventional or classic computer, how can I wrap my head around that?
I think of it as part of a continuum that we've been on for a long time. Similar to you said, we've been on the AI journey for a couple of decades. We've been on sort of how do you deploy advanced computing and simulation to speed up design, modeling, or whatever for a long time. So for example, if you're building a car, used to be you would build like clay models of the car, and then you would put it in a wind tunnel and you would test it and put some smoke and see how it's doing on aerodynamics and stuff like that. Well, people don't do that anymore, right? They use high performance compute clusters, they use commercial CAD programs to design the car, put it together in a digital realm before they have to go build something in an actual garage. They run computational fluid dynamics simulations on it, and they're able to design cars that perform much higher, much faster than they could if they're doing it in a garage somewhere, right? And quantum is sort of like another step in that direction. AI helps too. AI helps scan the solution space much more quickly to zone in on the problem areas that can be resolved more quickly. Quantum will start to layer in two things. One is where outcomes are not deterministic and they're probabilistic, they're able to compute much faster. That's great for financial services, risk mitigation, optimization problems, things like that. But they also will allow us to simulate things at the subatomic level, the quantum world, right? The physical quantum world. And we will start to inform other simulation models or AI models with what's actually happening at the scale we just can't see. And that's just another level of intelligence that we'll be able to build into these systems for drug design, for material science, for better battery design, for applications like that.
How much money is being put into quantum right now, and who's putting it in?
In the last month, $4 billion worth of investments have been announced, both in the public and private markets. I think if you go and check your stock reports, some of the highest returns this year are the AI stocks and the quantum stocks. Hardware is popular again. It's not just software like it was 5 years ago. JP Morgan just announced a big thing on Monday. It's like a $1.5 trillion fund over the next 10 years that is going to have a deep tech component. It's one of 4 components that quantum is named as one of the 3 kind of frontier technologies in, and they're putting in $10 billion now towards that. So there's a lot of money flowing in, and it's increasing at a rapid pace.
Now that's in the public sector. What about sovereign fund investment? What does that look like, and why, what use case would a sovereign entity have for quantum compute?
Yeah, so what we're seeing in this global competition, especially as we're having more kind of nationalism and tariffs and this kind of stuff going on, is we're starting to see, it kind of started with semiconductors 10, 15 years ago between the US and China. We're seeing it in AI in spades now, hypersonics, and quantum. These are strategic technologies that no responsible country that cares about its economy wants to be left behind on, right? So you're starting to see investments in all these categories I just said for national security and or economic security come in so that they can make sure that their workforce is able to take advantage of these technologies. They're trained on how to program quantum computers or AI systems. They have ownership or control over the systems. They have quantum computers on premise somewhere in their country so that they can't be denied access. Same with semiconductor manufacturing, same with other capabilities. So what we're seeing is in the Middle East, in Europe, in Asia, and in the US, we're seeing a lot of government investing in quantum computing in particular to make sure that they can advance that capability and have control over it. And while this technology is still scarce, I think you're going to see that competition trying to increase. At some point, it'll be commodity and it'll be available everywhere, and this won't be an issue. But that's a while away, I think.
So I swear this will be my last quantum question, but it's really, really important. So there are different kinds of quantum computers that are being built, right? They call it modalities, different constructs of the computers that are being built. And you are in a field, you have been working in a field called neutral atom technologies, right? Versus more of a classical compute perspective that might be on a supercooled hyperconductive substrate, right? Can you bookend those two things from the perspective of footprint and energy consumption?
Yeah, I will. Just to be clear, I'm not working on neutral atoms currently.
Understood.
I'm working with a number of different companies across the different modalities. But what I will say is that the different, think of them as hardware architectures, the different approaches to how you build a quantum computer, they're not all created equal. And they all have different strengths and weaknesses when it comes to the various performance attributes. You referred to neutral atoms. Neutral atoms are one of the more scalable and energy efficient modalities. There's a lot of investment coming into that, and a lot of partnerships that are out there between major companies and some of the startups that are working on them. The systems that atom computing was building, for example, or is building, they were a few kilowatts of power per system. Today's racks of servers are about 40 kilowatts going to 100 kilowatts. So one server's 2,000 to 4,000 watts. So we're talking quantum systems that are like consuming power that's something like a few servers, which is kind of crazy because the performance of these things is going to be like orders of magnitude greater in some types of computation that they can do.
Yeah. Okay. Thank you.
Yeah.
So we have AI deploying, and it's making us all more efficient. We have robotics, and I'd love to actually poke quite hard at that automotive building question as you think about the use of robots in that environment and how it's emerging and changing over time. And then we have the supercharging of quantum that will arguably how do I put this in words? When you think about how much better the latest GPT environments are compared to what they started with back in 2022, right? That's because they're starting to take in more variables to be trained on. So now what are we up to now? What's the latest? 5 trillion? 5 trillion variables are absorbed.
Oh, no, it's 1.5. So I thought GPT, 1.5.
1.5, sorry. 1.5, it doesn't matter. Anything over a few thousand is pretty impressive, right? 1.5 trillion variables are being pulled in, and it's causing rapid improvement in the capabilities of the technology. Quantum supercharges that, right? In some ways, it's going to enable and allow, we believe, it's the biggest unknown because it's the least deployed at this point, but it's going to enable another kind of a stair step in the capability and the reasoning capability, the probabilistic capability of AI, which is the gap on common sense, I think, that GB was talking about from a robot's perspective. So when I start to tie all this together as a student at the school, looking at employment, or as an employer at the school, looking at how they should be adopting these technologies, how do you think these all start to collide over the next 3, 5, 10 years? Ben, you have thoughts on this?
Well, I think the only thing we know is that that they will collide and they will create value, and just like existing technologies have combined to create incredible value in different ways over the last 10 years, and that pace just continues to increase. And so then as a student, you look at what does that mean for you in your career, and how do you prepare yourself for a world like that? I think the first thing you can do is, be very adaptable and be committed to continuous learning, and use the tools that you have and be as familiar as possible. And I love what you all are doing with Boodlebox, et cetera, things like that. But also, it's about fundamentals. All of these technologies and all of these solutions we're talking about are in the context of an industry. And so getting to know an industry and the context of an industry and the challenges of an industry is a good way to make yourself relevant in any environment. And so to me, anchor yourself in an industry, figure out an industry that you can get very familiar with, because then you can figure out how all of these different technologies can help you improve. And so that would be my best advice on it.
Okay. GB, how about you? Let's talk
Yeah.
about what you think it means.
I've often thought about this in the sense of, is it better to go broad in this new AI age or go deep? Right? It's a tough question to answer. So the way I look at it, at least, is if you want to go deep, you better be the top, really top, like 1% kind of deal, right? There's more hope in the broad category, in my opinion, humble opinion, because AI, Ben, you will agree with this, right? You have applied AI and foundational AI, right? So my 2 cents is everybody should get ahead of applied AI. Otherwise you'll be left behind.
What do you mean by applied AI?
Using ChatGPT is part of applied AI. Being able to use AI tools, right? Being able to advance your work using AI tools. There are a lot of things out there. If you take this approach of, I'm anti-AI, I don't want to use AI kind of approach, you'll be left behind. So, but foundational AI is a whole another category, where you have fundamental algorithmic math level changes happening, and that's a whole other category. But in my opinion, everybody should be on top of applied AI.
Okay, so just say that a little bit differently, right? You said don't form an opinion right now, pro or con, on AI. Just be curious about what's coming.
Just be curious.
He paraphrased Ted Lasso there, right? Be curious, not judgmental, right? I think it's right. I think we could, as a group in the community of Tulane, take the 4 o'clock hour on every Wednesday and commit that you're going to put in your calendar an hour-long block where you shut everybody out and you go to a trusted source and you learn something new about all 3 of these technologies, because they will impact every industry. Like these are the horizontals. The reason the guys are here right now today as the starting discussion is these 3 technologies will impact every industry over the next decade, okay? And what we'll do in subsequent sessions is we're going to actually do, Ben, that deep dive, and healthcare is our next one. It's going to be fascinating. Rob, what about you? Thoughts for how these collide and what it means to students?
Yeah, I'll give 2 real-world examples that I've heard from customers that I've interacted with in the market. That there's an intersection between, I'll say, robotics and quantum computing and what you consider heavy industry. The first one is a large aerospace company, American company, building airplanes. They build these planes, many of them out of carbon fiber. And the way carbon fiber, it's just sheets of fiber, and they get laid in multiple different directions so that they're very strong in all directions and flexible or not flexible depending on what properties they want. And the whole name of the game is to have the strongest plane with the least amount of weight, right? So you want to use as few fibers as you can, but you want to get it right. So they're trying to use a quantum computer and maximal independence set, algorithms to try to figure out how to basically design the carbon fibers, so not just random placements, which is kind of what they do today, but actually design in a certain way to kind of weave these things together. So that's like one example, and they can use that in a manufacturing environment. It's repeatable, and it'll ultimately save energy and improve performance. The other one is a company in Denmark that basically creates the machines that paint shipping containers and windmills and things like that, like large ocean-going ships. And they want to use quantum computers to figure out how to get the right formula of the paint to bond to the ships with the least, again, amount of weight and the most resiliency and things like that. And so there's algorithms they're using to go do that. And so these are painted with robots as well and things like that. So I think that it's going to hit a lot of different these technologies will hit a lot of different industries, even if you don't think they will. So my advice to students or anyone who's looking to advance their career is to start to think about what are the types of algorithms or mathematics that lend themselves to a quantum computer. It's not all math, it's not integer math, things like that. It's certain types of math. You can find that easily probably through ChatGPT. And then how does that apply to your industry that you're in or you desire to be in? And so you can start to think about those use cases. You don't need to be an expert in quantum physics or how to program the systems, but if you're at least aware of those use cases and do some research on what are the capabilities of the systems, the scale of the systems, or whatever that need to be available to realize those use cases, then you can start to create a roadmap for how quantum computing or robotics or AI can impact your industry and give you a competitive advantage. And if you don't do it, your competitor will, and you'll be disadvantaged. So that would be my advice.
Great. I'm going to hit pause for a second and see where I am on time. I think it's a gear shift time to go to questions if you all have questions for us. So, yes, sir. And afterwards comes, because you will get a signed book. All right. You know what? We have a microphone coming so everyone can hear you. Thanks. Thanks, Nick. Does everyone know Nick? By the way, he put like this whole thing together. So mad respect, Nick. Thank you.
So thank you for the insightful comments. My name is Sandeep. I'm an assistant professor here. So I study how industries are born and how they evolve in my research. One thing when we look at historically with technologies is they do allow us to be more efficient in the set of activities that we are currently engaged in, which is what I mostly heard. But a lot of it is they allow us to do a very different set of activities that we have never been able to do before as mankind. So be it electricity, be it the internal combustion engine, be it microprocessors, etc. And recently the Nobel Prize was given to how innovation affects growth, right? And a lot of the growth from innovation, there is efficiency, but most of the growth comes from new sets of activities that are being things. So taking the futurist part very seriously, I just want to ask this question. What are the new industries that you think will be born, right, in your opinion, that you are predicting today? I understand it's a prediction, but a complete set of activities that is beyond just making what we are doing a little faster, a little more accurate, right? New set of activities. Thank you very much.
Cliff, isn't that the subject of your book?
Not exactly, but it could be. It could be. Well, do you want to take a cut at this, or you want me to?
Please go ahead.
Okay. So look, I grapple in my daily job with the question of 9 zeros growth, so billion-dollar growth for our clients, through the lens of, but for generative AI, would not exist. What are the things that clients can do now as a result of AI in either serving an existing customer or creating a new capability for an existing customer or attracting a new customer? Those are the basics of the revenue streams that we would associate with innovation. And the answer is, in the near term, it's still unknown. And the reason it's because we're too early. And the reason it's still unknown is because most of the investment, if we really, really dig into the investment that's being made so far, it is about efficiency and it's about cost takeout. So if the profit equation is revenue minus cost, we're focused almost entirely on cost. And the hard part about the real reason I believe that we're not seeing the kinds of return that the technology would allow is simply because as humans, we're not deciding to make the decisions that would enable the technology to provide that kind of return for us, right? We don't trust it enough yet to lay off 50% of our workforce to drive the efficiencies and the ROI gains. We don't trust it enough yet to, contract to drive an incremental billion-dollar market doing sales motion that we've never done before. Like the markets are just not that far yet, but they soon will be. And so I think predicting which particular service will emerge in which industry, I think that's the trillion-dollar question and not one that we can answer yet.
I would my perspective, I kind of live in the Silicon Valley, startup ecosystem, and so I have a different perspective. Not working with large companies as much anymore, but there's amazing technology coming out of these incubators. There's amazing technology that's being funded by venture capital, and not just Silicon Valley, but using that as an example. I would say go to some of these incubator programs, go to the entrepreneurship programs. You're going to see some amazing things coming out. It's hard to predict. Like, if we could predict which ones are going to succeed, then we'd all be billionaires, of course. But that's why I like doing what I do. Is I get to work with right now with multiple startups and bringing really innovative technologies to market that are net new at the end of the day, and they're driving the top line. Growing the top line, right? And maybe not profitable yet, but eventually, we'll get there. And a lot of them are enabled by AI because they take take the grunt work out of some of the stuff, and they allow people to go off and think about new things.
I think of it kind of as like resolution. We used to have phones that gave fuzzy pictures, and now they have high definition pictures. And the same is true in business with compute and with AI. It's allowed us to do more in a richer way that then allows new avenues of growth to be opened up. So I can't predict net new segments of the economy that could be created. Certainly robotics could be a dramatically different segment of the economy in the future. But I can say that if you think about just the way businesses run today, when I first started, we used to put expense envelopes in the mail, and 1 out of every 1,000 of those would get audited. And today, every single expense that everyone submits is audited to the penny. And similarly, when we look at marketing and things like that, we used to have marketing campaigns where we'd have one campaign for a country or a region. And now we can have hyper-personalized campaigns that will get even richer and more personalized and more specific, et cetera. So those are avenues of growth. They're enriching the depth of the work that we do, and they can create growth, and they can create efficiency, and they can also create more work. But it's hard to predict what the next mega segment would be. But if I was to make a bet on the stage, I'd say that robotics is probably one that would radically change, and you could imagine a world in which that's something that's a completely new segment for many people.
Yeah, now, I would agree with Cliff as I always do. We are not there yet. I think we are still in survival mode. I think we are still in the how to build mode. If how is taken care of, then you will graduate to why we are building what we are building, right? And it'll happen, And for now, we don't have the capacity to imagine yet, because we still have to take care of all those mundane stuff even today. And when that is taken care of, I think exploration, it'll be a time set for exploration, and we'll get there.
I see a lot of, there's a lot of amazing, think about the basic needs of human. They need a safe and affordable place to live. They need healthcare. They need entertainment. They need, connectivity and all that. And there's so much innovation going on in these areas across a number of different, not just startups, but some large companies as well. Again, hard to predict what the next big thing is, but I would just think it's going to show up in some of these basic needs at least.
What I can predict is that over the next 5 years, we're going to see massive flux in the leaders within existing markets, those who adopt and those who don't.
Yeah.
Right? There's a real challenge for incumbents to maintain relevance if fundamental business models are being disrupted. Right? We no longer. The services industry is something that we spend a lot of time on, and the reality is there's a huge impact pending on how we think about quality and good financial performance in our craft. We don't know yet how it's going to play out, but I think we have a real chance to lead in a new order of things because we are embracing AI. I think companies that stick with law firms, law firms that stick to time and materials contracts and chargeability and hours per attorney instead of outcomes, and look at the caseload that an attorney can handle, or a paralegal can now handle on behalf of the attorney in a quality fashion. I think those law firms are going to lose share. They're going to lose speed if they hang on to the old way of doing things. So situational awareness is super, super important. Yes, new things are going to be created. I think they're going to be created under the umbrella of existing entities, at least in the next decade. There will be, I'm sure, things I'm not aware of that will come in and prove me wrong, and I hope so. But I do know the thing I would be watching out for if I was in the market right now, if I were in the audience and either an owner of a business or an employee thinking about taking share from competitors, I'd be targeting those that are not yet embracing the potential of the toolkit that now exists in the world.
We could see signs of it. I mean, if you put quantum and AI together, who knows? We could see cancer cured. No cancer in our lifetime.
But that would be healthcare.
Healthcare.
That's the next. That's an
That would be
advertisement for your
healthcare,
next
right?
session.
Like we're talking about a whole new industry emerging. Yeah. Anyway, I'm sorry. Please. Yes.
I just want to book.
Okay. Good.
Thank you. My name is Alex Sleptsov, and I'm teaching various strategic management courses here at Freeman for 21 years now. Oh my God. Normally, in all of my classes for the last 2-3 years, I would have a few AI enthusiasts, the students.
Yes.
And by AI, of course, I mean very narrowly LLMs. When they start telling me that they want to do a big project on LLMs, I usually tell them, well, hold your horses. Don't be so enthusiastic. And the reason is that in modern organizations, actually in all organizations, competitive advantage exists because it is based on tacit knowledge.
Yes.
Right? And tacit knowledge, by definition, is a knowledge that cannot be codified. It cannot be even articulated. So organizations know how to do something, but nobody can explain exactly how it is done. So it is not encapsulated in language. So I'm saying that, look, LLMs can never actually understand how organizations work because so much of that is tacit. So my first question to all of you is, am I wrong to tell that? And the second question, if I'm not wrong today, when will I become wrong on this statement?
Okay. Thank you. I'm gonna let Rob go first, and then we'll work down to me. But I have an answer on this. I think you're wrong. Sorry. Okay.
I don't know if you're right or wrong, but I, on an almost daily basis, use LLMs to try to understand organizations in one very simple way, which is org charts. Who reports to who, so I know who to call to get something done. But you're thinking on a different plane than I am, so I don't know.
GB?
Yeah, I mean, again, there is this debate of, with all the goodness of ChatGPT and generative AI, is it really a memory function or an intelligence function, right? Obviously, it can parrot everything it has seen before much better than you and I, but can it, when it gets to creativity, when it gets to intuition, when it gets to taste, when it gets to really sensing the context, I don't know what it is. It's not just looking at patterns anymore, right? It's about your life experiences, especially organization is an organism, right? It has a lot of context associated with it. And also the other challenge is data. I mean, these are private data that nobody gets to play with. So even if you get access to that, I think there would be fundamental limitations, in my opinion. So I don't know what my answer is. Maybe in the middle?
Yeah, I think it will never, until we have human level intelligence, it will never be able to answer that question the same way. So it's that may be the tipping point, is when we have human level intelligence, that you get that same level of understanding. But I think the data moat is a lot bigger than people think. And I think that's maybe the thing that a lot of people don't understand about all these tools is the data is critical to effective use of the tool and reliable use of the tool, and safe use of the tool. And so the data moat that exists in most companies is not something that's easily broken down. I think that's a great point around the data.
So I think that in the use case you're talking about, which is, should I allow a student to use LLMs for a large-scale project because they will, if I'm saying this right, make sure I'm saying it right, that that they won't learn their own intuition or intangibles about the project that they're doing. Yes, am I sort of?
I'm not allowing.
Oh, no, I understand. No, there's a huge debate. Will ChatGPT? MIT released the study, right? It showed a brain that uses GPT is different from a brain that doesn't, right? And immediately, alarm bells went off, and I think there was a contraction in some circles. Look, at the end of the day, I think you need at least one class in the business school per year that is entirely driven by GPT or LLM, and the exam is verbal. It is a panel that sits and grills the individuals on what they've presented as the solution from GPT, right? Because it's a better writer, it's a better researcher, it's more efficient. I'm going to expect them to be able to do that when I hire them, right? And then our role as advisors is shifting more and more towards that last mile. Do you get the intangible if the data you're ingesting is outcome-based? Isn't it implicit in it that an outcome depends on intrinsic knowledge? And if I make the data mass so large, if I use so many examples in the data to form my opinion, probabilistically, won't I be more right than wrong? Won't I already incorporate that intrinsic belief? That's kind of my offer. I don't know if it's right, but I definitely think you need to encourage a toolkit use backed up by real knowledge. Like, don't let them get away with, sending something in they don't understand, but definitely teach them how to use these tools because they're super powerful. Yes, ma'am.
Hi, my name is Michael Wield. I'm a junior studying computer science and artificial intelligence at Tulane. That was a very interesting question. Unfortunately, Professor, I haven't had an opportunity to meet you. But I wanted to raise a topic to the panel, and perhaps you could just enlighten me a little bit more on what's going on in terms of different sorts of avenues aside from large language models, how companies are, how the dollar is being spent in improving these systems. So some of the research that I've been doing has been on multi-agent systems and basically how using multi-agent systems instead of, say, I suppose you could think of a large language model as one person with really advanced deep reasoning capabilities to solve problems, right? When you improve the perspective in problem solving, which is precisely the reason why as humans, oftentimes we operate in groups when we problem solve. I mean, even in junior analyst roles, for instance, over at Accenture, I'm certain that in the hiring process, you want people that have a diverse skill set because it effectively allows them to have potentially add an additional perspective that effectively allows people to problem solve better. So I just want to understand a little bit more about how the landscape with the investment in multi-agent systems, whether or not you think that there's going to continue to be a reduction in these junior positions over the next couple of years as reasoning capabilities of large language models ultimately increase, and if we see a shift into more money being spent into multi-agent systems, how you think that's going to affect the overall landscape of the businesses that you're in. Thank you.
Yeah, I mean, I think the most important part of that question is especially that at the end, which is, what does it mean for the pathway, the career pathway of people? But, without a question, multi-agent and orchestrated models produce better results and will continue to be, the more different, different agents that are working on something, the better the result will be. And that's, as the cost of those agents goes down, the more agents will be used. But the big question is, what does that mean for the career model, and how to, will we need the same number of people coming into the model, and then how will we develop people? And those are super complex questions. I believe that there's always going to be a need for the human workforce to do many of the same tasks that we're asking AI to do. It's going to be important both in terms of quality control, positioning, and advising our clients on it, bringing credibility to it. We are going to have different growth pathways for people. People will join, and instead of doing the things that they used to do, they'll do slightly different things. And I'll look at the evolution of analysts at Accenture over the years, and it's radically changed since I've joined. When I joined, we spent the first 2 or 3 years cranking through Excel models, and we did that on our own. And today, that's largely done offshore and done with very different technologies, and it's now done in an increasingly very automated way. But we learn to spend more time with our clients and understand the industry more, and spend more time understanding the business processes and getting the right context so that we can actually position recommendations in a way that makes logical sense for a client. So the nature of the work will shift. I think it will provide an opportunity for some people to move up faster because they can grow skills faster with an accelerated, kind of wind behind, a tailwind of technology behind them. So I see there's always going to be a need to grow the next generation of leaders, but that will just happen in a very different way. And we are continuing to hire at the same levels that we have hired in the past, because while we believe AI is an accelerant to our business, which it is, because more clients need more help to figure out, what to do with it. We also think that we'll be able to use that capacity in, new and better ways to do, sort of more work to create richer results. So, I don't think it will ever eliminate the need for, for the direct hires. I think right now, especially in the near term, we see, very optimistic that we'll need a lot more and not a lot less.
So I'm pretty sure you have an open spot in the MBA school after that question, which was awesome. Yeah. And come talk to us when you're ready to enter the workforce. We'd love to hear more. But yes, I'd agree with Ben. The reality is we expect to see the cost to train models to decline over time on the average model, and investment to be made on the bleeding edge model over time, right? And so disruption will occur because people have been working on it now for 4 or 5 years that I know of, looking to break the cost implications and the quality implications of the current training methods. So, yeah, I think we'll see it continue to be a solution that's pursued. Last question, and then I'm going to let you guys go home for dinner. But you both get a book. Okay, 2 questions. Can we make them short? Okay.
I'm from Nepal, Southeast Asian country, and thank you all for this wonderful session. I'm a Master of Accounting student, but technology, it's been really inspiring to be exploring things. My question is, unfortunately, not towards the creative aspect of it all, towards the accountability aspect of it, as Cliff was kind of hinting earlier. My thing is, we use a lot of tools and everything, but ultimately a face has to be attached to kind of, handle the responsibility of the decision. So basically all the large language models or whatever technology, neural networks, whatever we're using, we don't exactly understand how it ultimately reaches its output. So in that scenario, who's to take the blame? How do we of course, everybody wants to take the pie for the winnings, but how do we, manage or manipulate or navigate that scenario of getting to a place where mistakes are very costly, but you have to assign responsibilities for those things? Is basically what I want to know.
Okay. Anyone want to take this on?
I can, please.
Yeah, that's, as they say, always be selling. That's a unique differentiation for Robots as well. It's one thing if ChatGPT hallucinates. What's the worst that can happen? You get a wrong word or a sentence. You can ask it again. But if the Terminator hallucinates, it'll kill you, right? So this is very important for us. In AI terminology, you call it explainability. You need to be able to explain what's going on inside the AI model. And when you have a 1.5 trillion parameter model, nobody has any clue what's going on inside. So we have done many unique things in our company to make the AI explainable. And one quick one, and there are a few things, but one quick one is break down the big models into smaller models, which we can debug, for example. And honestly, that's how human body works too. I don't know if you have seen a chicken run around with the head cut off, right? It can run around for 45 minutes without a head, without a brain. So the spinal cord has the circuitry to move the legs and fly.
We cook it in jambalaya here before that happens. There's no one who lets it run around.
So being able to distribute compute, because brain is, by the way, brain is very close to quantum, right? But brain is analog computer, finally. So quantum may get us closer to the brain. And all of it works under 20 watts, which is the power that a light bulb consumes. Because you cannot have it more than that, because if it takes more calories that the food gives than to hunt for the food or to eat the food, then you won't survive, right? So my long answer short, yeah, that's a key. What you touched on is a very key aspect of AI that a lot of people are spending time on, and it becomes more and more important when it gets to physical AI. You need to be able to explain the AI, what's going on inside the AI. Otherwise, you can't deploy it.
I'll just add 2 cents, which is practical for you as an accountant in the workforce once you get your degree. You better double check everything, right? Attribution's important, but checking the attribution is more important. Look, I joked with the guys earlier about the first time I saw a use case in growth strategy for AI, and it made my heart rate. I run at a cool 60 beats a minute, and I went up to 135 beats a minute and panicked for the entire weekend. And then I realized something, and I went to bed and slept like a baby, right? Trusted advisor is a critical role, and that doesn't change in the future. If a quantum diagnostic through an MRI diagnoses that you have a need for immediate surgery by a robot through an AI lens, you're still calling me, right? Before you let anyone touch your brain, because you need a trusted advisor for really, really important decisions. Taxes are pretty important to most of us. And so I think it's not so much how do I apportion the blame, it's how do I prevent the error from occurring as I use the tools that you have to think about and stay that trusted advisor, which means if you do screw up, you face up to it early and honestly, and then you earn the trust of the client as you deal with what the problem is. Yeah? Thank you for the question. Okay, one last question, and this is it.
Okay, I'll make it quick. First of all, thank you all for being here. I've learned a lot from this panel. I want to switch focus to hardware, in particular with robotics. So you mentioned that like the 4Ds, there's a lot of menial labor and menial tasks or dangerous tasks that we want to sort of get people out of the workforce for and replace robots. Well, currently, we see that a lot of employers or a lot of these business owners don't want to employ robots because they're really expensive. And we have seen a rise in like rapid manufacturing and prototyping to get things done quicker and with less steps. But take the example of, say, a dishwasher, where it exists sort of in the realm of being really dull and repetitive, but it takes just enough precision and detail to where like a 3D printed robot probably can't do that. What's the next step in moving from doing really, really basic tasks to doing the things that those jobs in the 4Ds usually require, which is generally some level of focus that you would need a little like a more advanced robot to do?
Wow, I couldn't ask for a better question. You know, I'm pitching
What a
my company.
closing question for you, GB.
Always be selling, huh?
Bust out the shirt
I
again.
know, there you go.
Learning, always be learning.
Yeah, I think we'll get there. And I wasn't joking when I said if you want to really democratize robotics, you have to get it to a laptop cost. Yeah, that's how, we can have a few in every house. And one technology that can get us there is 3D printing, right? And the way 3D printing helps is it itself make a robot and push out another robot. So I think we are. I would even tell you this, right? Our BOM cost for our robot, it's a humanoid robot, it's under $5,000, right? So we, with a little bit of time, I can see it going to 2,000 or cost of a laptop. So and these are generic robots. Humanoids are generic robots, which can also wash your clothes at some point with AI. right? So you don't have to wait too long to get to what you're just saying. Yeah.
I'm just excited about being able to toss my pants on the floor and have that picked up. So that sounds awesome. I'll never have to hang a clothes again.
Not in my house. I have to pick them up. So anyway, look, I want to thank you all for what I hope was a good and fun session for you. Thanks for sticking here for 90 minutes, giving it a try. We have 2 other great sessions planned. The next one will be on healthcare. The subsequent one will be on private equity. So really appreciate Dean Goes and Ashley's support here, Assistant Dean Francis, and Carmen Weigelt for her patience with me as I stumbled about learning Tulane's infrastructure and how to best approach. And last but not least, Brent for his unbelievable patience again and willingness to work with us to put this together. So phenomenal job there. Thank you all. We'll let you go home, and we appreciate all the panelists who came and traveled from around the country to be here today to talk with you. Okay, thank you.
Thank you.